Welcome to the DIY Honda Garage channel. This troubleshooting guide provides comprehensive instructions to diagnose and resolve the diagnostic trouble code P0141, which indicates a secondary HO2S Sensor 2 heater circuit malfunction in Honda Accord models from 2012 to 2017. The DTC P0141 specifically refers to issues within the heater circuit of the downstream oxygen sensor, critical for proper emissions control and engine management. Accurate diagnosis involves verifying system status, checking wiring and fuses, testing the sensor's internal resistance, and verifying circuit continuity. The process also includes checking the PCM and harness connections, as well as ensuring the ECM software is up to date when necessary. Each step in this guide is designed to isolate potential causes, whether a failed sensor, wiring short, open circuit, or PCM fault, leading to efficient and effective repairs. Proper adherence to these steps ensures accurate fault detection and restores vehicle performance and compliance with emission standards. The initial step involves verifying the presence of DTC P0141 using the Honda Diagnostic System HDS. Record all freeze-frame data, which provides snapshot information when the fault was detected, assisting future diagnostics if the issue is intermittent. Clear the existing DTC to ensure the system is tested under fresh conditions. Start the engine and let it idle normally to observe the system performance under typical operating conditions. After a few moments, check the HDS for any pending or confirmed DTCs related to the secondary HO2S heater circuit. Confirming whether the DTC reappears helps establish if the fault is persistent or intermittent, guiding subsequent troubleshooting actions accordingly. In this step, turn off the ignition to safely inspect the electrical system. Locate fuse B13, rated at 15 amperes, in the under-dash fuse or relay box, which supplies power to the IG1 ACG line, a crucial power feed for the oxygen sensor heater circuit. Verify the fuse is intact. If it has blown, replace it, and investigate the wiring for any shorts or faults between the fuse and the sensor. Replacing a blown fuse without correcting wiring issues can cause recurrent failures. If the fuse is in good condition, proceed to further testing of the circuit, knowing that the power supply to the sensor's heater circuit is verified proper at this stage. This step tests the internal heater resistance of the secondary HO2S Sensor 2. Disconnect the sensor's 4-pin connector at the vehicle side to prevent interference, and measure resistance between test points 1 and 2 using a digital multimeter. The specified resistance range at room temperature is between 5.4 to 6.6 ohms. Values outside this range indicate a defective heater element within the sensor. A resistance lower than the specified range suggests a shorted heater coil, while higher values imply an open circuit, both of which compromise sensor heating capability. If the resistance does not meet specification, replace the sensor, as a faulty heater can prevent proper sensor operation and trigger the DTC. Assessing the internal circuit integrity of the sensor involves testing for continuity from each terminal to body ground. With the connector disconnected, measure resistance between terminal 3 and ground, and similarly between terminal 4 and ground, to ensure no open circuits or internal damages. Continuity indicates the internal wiring and heater circuit is intact. Lack of continuity suggests internal damage, broken wiring, or faulty connections. A failure in these checks warrants replacing the entire sensor, as compromised internal circuits can prevent the heater from functioning correctly, resulting in persistent DTC P0141. This step involves checking the SO2 HT line, which carries the heater power signal, for potential shorts. Jump the SCS line using the HDS tool to simulate the sensor's heater circuit conditions. Disconnect the PCM connector C, ensuring no interference from the PCM's control circuitry. Using a multimeter, check for continuity between the test points on the wire and body ground. Continuity indicates a shorted wire to ground, which can cause the heater circuit malfunction. If a short exists, repair or replace the compromised wiring. If no short is found, the wiring is likely intact, and the diagnostic proceeds to the next step, focusing on other potential causes. An open circuit in the SO2 HT line can prevent the heater from reaching operating temperature, causing the DTC. Disconnect both the sensor and PCM connectors to isolate the wiring. Measure continuity between terminal 4 on the sensor connector and terminal 9 on the PCM connector, both corresponding to the heater circuit. If continuity is present, the wiring is intact. If not, there is an open circuit in the wire. Repair any open wiring, which may involve splicing or replacing damaged cable, ensuring the heater can receive power. Confirming open or short circuits helps localize faults precisely, avoiding unnecessary replacements. The final electrical check involves confirming that the sensor receives proper voltage supply. Reconnect all connectors securely and turn the ignition to on, ensuring the system is powered. Measure the voltage at terminal 3 of the sensor connector, which supplies the heater circuit, using a multimeter. The voltage should match the vehicle's battery voltage, typically around 12 volts. If there's no voltage, inspect the wiring from the fuse and under-fuse/relay box to the sensor connector for open circuits or faults. Ensuring proper voltage confirms the sensor's internal heater and circuit wiring are capable of functioning correctly, vital for eliminating the DTC. The final step involves resetting the vehicle's powertrain control module to clear stored DTCs and ensure the system resets to normal operation. Reconnect all previously disconnected connectors. Exit the self-diagnostic mode with the HDS tool and reset the PCM. Follow the specified procedures for PCM reset and perform an idle learn procedure to recalibrate engine parameters. After completing these steps, monitor the PCM's OBD status to confirm that DTC P0141 has been successfully cleared and does not reappear during normal driving conditions. Successful clearance indicates that the issue has been resolved and the system is functioning properly, but continued observation is recommended. Please like and subscribe to the channel. See you next time.